Okay, so we are in our chapter 6. Number of people somehow missed your Unit 3 test. I don't know if that was anybody in here or not. I'm not saying to anyone specific. But do keep in mind that if you have when you take your final exam, that will replace your lowest test grade. So let's say you made one test, you had like a 64, and on your final exam, you've got like an 82. Well, that 64 and your final exam will be an 82. So that will also cover you on a zero, but then any low scoring ones you get to keep. I will probably be changing the due dates for chapter 6. I think I have them in there a little bit early. I'm not sure, but they shouldn't be due until I think our chapter 6, our unit 4 test is on like the 22nd or something like that. So I might be changing the due dates on 6. 12-1. I do not have scheduled on so we're going to kind of do that a little bit independently. How are we at remembering elimination? Systems of equations by elimination? No? All right, well, maybe we need to get that in there a little bit. 6-5, I want the whole classroom. 6-6, we might, squeeze some in, and then we have a review night, and then we have 2 test nights. Then we have a review night for our final exam, and everybody knows their final will be online, right? Okay.
Miss White?
Yes, ma'am.
Are the 2 tests, like, from the now to the end of the semester, are our tests online, or are they, like, in person, other than the final?
No, we have one more test left. That'll be in person. Your Unit 4 test on Chapter 6 and 12-1. That'll be in class, and then there's the final exam.
Which is online?
Yes.
Mm-hmm. Okay, thank you so much.
Mm-hmm. And then every time, I don't know, I was looking at it today. I tried to spend a little bit of time on making sure everybody's grades are updated, and I have 2 people I know are going to shoot me because I still don't have their Unit 2 test in. But it seems like every time I update, so MathLab so Canvas will pull your MathLab grades in. It's putting in a dash, a no grade, where you haven't done stuff. And I got to go back and put in the zeros. So do be aware that if you have blank grades, assignments you didn't get, and I have some setting not correct, because when it updates, it doesn't update as a 0, it updates as a no grade. And I got to go back in and put those zeros. Do be aware that if you have that those are going to 0. Okay, so make sure you're getting your assignments done. All right, so you know what a function is, right? You got the vertical line test and x cannot repeat. Okay, so the only thing when we are looking for a function that is 1-to-1, we start looking at y now, okay? A function x cannot repeat. Every x must have just one y. Well, now it's a function, so I know my x's won't repeat, but I got to check out those y's to answer the question, is it a one-to-one function? So like on 17, I got 2 6's in the y. And it's actually, it seems like really, really easy, but it's kind of hard to transition from looking at x all the time to checking out y, right? So be careful with it. This is going to be a no. 5, 3, 7, and 12. That gives me a yes. Okay, when I'm talking about a function, x cannot repeat. When I am talking about a one-to-one function, nobody repeats. Neither x nor y will repeat. Okay? Yeah, we're recording. All right. And then you know how you have your vertical line test when it comes to a function. You drag the vertical line across the graph, and if it doesn't touch the graph in more than one place at a time, well, on a one-to-one function, you have the horizontal line test. So I can drag a horizontal line across a graph. That's going to fail, isn't it? Because I am going to be touching that graph in more than one place. That means I have 2 of the same y. We would fail my horizontal line test here. So that's not one-to-one. Where else would we fail on this one?
26.
Yeah. I mean, that is nothing but a horizontal line, right? So this is another fail. Not one to one. But all of these they're going to pass. None of the x's nor y's are ever going to repeat. X and y is changing continuously, right? So all of these would be considered one-to-one. Okay? So that's all there is on that. The only dangerous part is that it's so easy. Sometimes we just kind of look at that x instead of the y. All right, so if we have a function of x, we call it f of x, right? And then we also have the inverse function of x. Now, what if I have a to the 1, that's just a, right? What if I have a to the negative 1? That's my 1 over a, right? That is my inverse. That's where I flip it. Okay? When it comes to my inverse functions, what we're going to do is swap the x and y. Just swapping x and y. We're flipping it over, just like we did with exponents, right? We flipped them over. So if I'm looking at the graph Well, let's say that I have a relation. If this is my f of x, then what is my inverse function of x going to be?
-3, 2.
Mhm.
7, 4, -8.
And take note, the error I always see on this is people change those signs because when we start talking inverse, people want to make a positive and negative. Leave the signs alone. No signs changed here, right? We just swapped x and y. So if I were to do the inverse, graph my inverse function, I have the coordinates 1, 2, 0, 1, -1, 0, and -2, -2. Those are the points I have on this graph. So my inverse is going to be 2, 1, 1, 0, and -2, -2. 0, -1, 1, 0. So go ahead and do that second one for me. Okay. So -2, -2 is going to stay the same. 0, -1 is going to become -1, 0. And 1/2, 2, right? -1, 0, 2, 2, 0, 1, and 1/2, 2. I couldn't really they're not always going to be symmetrical with the origin like these two are. Okay? So do please pull your points and flop them over. Okay? All right. Just that beginning stuff. I'm actually going to do this a little bit backwards than what the textbook did. We're going to write the inverse function. So I'm down on 46. I'm going to go back up to those other problems. But if we're gonna write the inverse, we're going to, 1, swap my x and y, and 2, solve for y. So on 46, instead of f of x, I'm going to write y because that's just what it is, right? So y, this is my 46, y equals 1 minus 3x. I'm going to swap that x and y, and I'm going to say x equals 1 minus 3y. Now all I have to do is solve for my y. I got to get this y alone, right? So I'm going to have to subtract 1 from both sides. So x minus 1 equals a negative 3y. And then I'm going to have to divide by negative 3. And I'm not going to leave that negative down here in the denominator, right? So I'm going to make negative x plus 1 over 3. The inverse function of x is equal to negative x plus 1 divided by 3. Just swap your x and y and solve for y. For 47, y equals x to the third minus 1. So x is equal to y to the third minus 1. I'm going to add that 1 on both sides. So x plus 1 equals y to the third. And I'm going to take the cubed root of both sides. So my inverse function of x is going to be the cubed root of x plus 1.
Like on a test or something, we write it as x plus 1 to the 1/3 power.
Yes, if it was open, that is exactly the same thing. Parentheses. All right, what about if I have y equals x squared plus 4? Subtracting that 4. X minus 4 equal to y squared. So I've got to take the square root of both sides. Now the inverse is going to be the square root of x minus 4. But I have to add something on here. Why do we have that? I've got a square root of x minus 4. Can't be a negative number, right? I can't end up with a negative value. So I have to say x minus 4 greater than or equal to 0. X is greater than or equal to 4. Just like they did up here, you have to have your domain. All right, what about f of x or y? I want to go ahead and write it in terms of y. Is equal to a negative 3 over x. What can x not be equal to on this one? X has to be, and cannot be equal to 0. But what about my inverse? X equals negative 3 over y. Solve for y. What happens? Ended up being the same thing, didn't it? All right, just one where we have some distributing a little bit more. What if I have f of x, my 53 here? Y equals x minus 1 over. So that's going to give me x equals 1 over y minus 2. Multiply by y minus 2 on both sides. Those two are going to cancel. And x times y minus 2 is equal to 1. I got to get that y by itself, so I got to get it out of that parentheses, right? The only way I'm going to do that is to distribute that x. So xy minus 2x equals 1. I'm going to add that 2x on both sides. And xy is equal to 1 plus 2x. One more step.
In this message, can x equal 0, because you can't have 0 in the denominator?
Mm-mm. Since I have one down there. Okay. And you're going to see this more and more where they do those little restrictions on that domain. How many of you are going to 14? The rest of you are like, no, this is it. No more. Get me out of this class and I am done. Okay. You get to go and get some trig.
Yeah.
Did you do trig in high school? Pretty. If you get those first basics down,
If I pay attention this time, I'll be fine.
all right. So this section here is when we test to see if they are inverse. And I don't know if you were with me last Wednesday, but when we tested to see if they were equal, if f of x was equal to g of x, or if f of g of x was equal to g of f of x, they both resulted in x, right? That's all this is. To test to see if they are inverse of each other, they will be f of x, f of g of x will equal to x, and g of f of x will equal to x. If this is true, you have inverse functions. If the composite function is equal, then they are inverse to each other. So we kind of already did these. I have f of x is equal to 3x plus 4, and g of x is equal to 1/3 of x minus 4. So what is f of g of x going to look like? I'm going to have 3 empty parentheses plus that 4, right? And in that parentheses, I have to put in my g of x, right? Because I have to replace my x in f of x with the g of x. So I'm going to say g of x is 1/3 times x minus 4. 3 times 1/3 gives me 1. So now I have x minus 4, because those two canceled each other out, right? X minus 4 plus 4. And those two cancel. G of f. 1/3 I need to get my f of x inside there, right? So when I take out, my f of x is 3x plus 4. Well, these two will cancel each other. And I've got 1/3 times 3x, and those two will cancel each other. So I get x. So my answer from all of that is yes, they are inverse functions. It's the same procedure, just a different question. So let's see what we get with, how about 35? 35. I'm gonna have x over 4 plus 2. When I distribute, that leaves me with an x plus 8 minus 8, which leaves me with an x, right? And if it doesn't come out to just an x, that doesn't mean you've done it wrong. It just means they're not inverse. And you're just going to say that. You're going to say it's not inverse. So I have for x minus 8 over 4 plus 2 for g of f. Gives me x minus 2 plus 2, which gives me an x. So yes, they are inverse, right? Can they be not inverse? Yes. Just don't worry about if you have to say no, it's just no. If it doesn't end up being there, then it's just a no. All right, so our first problem, this begins R23 here. And our first one, and I meant to grab some calculators from upstairs, but I just want you to, you're gonna have on your calculator, you're gonna have a button that says either y to the x, and you would put in 2, then hit this button, and then 2.7, or it might be x to the y. You might have a cap button like that, like it is over the 6 on your keyboard. 2 button 2.7, just so that you know how to use that to estimate. What do we get for 2 to the 2.7? 2 to the second is 4, and 2 to the third is 8. So we know it's got to be between there, right? What have we got for 2 to the 2.7? No one got an answer?
6.49.
Okay. Does everybody agree? Just make sure you are able to use, and then as another reminder, just some other things we're going to need. What if I have 2 to the 0 power? What's any number in the world to the 0 power? Right? Always a 1. I know.
Yeah, that's the new.
Okay, and everybody, I still answer 0 on that when I'm making keys. And what if I have 2 to the 1 power? 2. And what if I have 2 to the negative 1? 1 over 2, right? Just some reminders, some things we need in our back pocket to work these problems. We're getting ready to go into logarithm, and the logarithm is the inverse of an exponent. Okay? So just to work on some exponential equations to start out with here. One thing we have to keep in mind, if I have a to the third is equal to a to the x, if those bases are the same, what is the only possible solution for x? Right? X has to equal 3. And I can even have that in the other flip side of that. What if I have 3 to the a equals x to the a? Still, if they're the same, the only possible solution is that x has to equal 3, right? If these are the same, if the bases are the same, then these have to be the same. Otherwise, we couldn't have that equal sign in between them. Same thing. If the exponents are the same, then the bases have to be the same. So all we're going to do to solve these beginning equations is make our bases the same. If I have 65, 6 to the x is equal to 6 to the fifth, well, the only possible solution I have is that x is equal to a 5, right? All right, what if I have 67, 2 to the negative x is equal to 16? I have to write that 16 as some version of 2. How can I write 16? I am so sorry. I do not know why these. How can I write 16 as a 2? 2 to the fourth. Is 2 to the fourth power is 16, right? So I'm going to say 2 to the negative x is equal to 2 to the fourth power. Got to make them the same. So that gives me that negative x is equal to 4 and x is equal to negative 4. Yes? This is going to continue all the way through 5, one version or another of this, so do make sure. How about if I have 1/4 to the x, to the x, to the x, looking at your problem 70, 1 over 64. Can I get that 64 in terms of a 4? Equals 1 over 4 to the and now it's going to give me that x is equal to 4, right? All right, let's do a little bit more of an equation on here. What if I have 5 to the x plus 3, looking at your problem 72, is equal to 1/5? I got to write 1/5 as a 5. How can I flip that over?
5 negative 1.
There you go. So I have 5 to the x plus 3 is equal to 5 to the negative 1. And that's just going to give me the equation x plus 3 equals negative 1. So x is equal to a negative 4. I'm going to up it a little bit. What if I have 4 to the x squared equals 2 to the x? 4 can be written as 2 squared, right? So I would have 2 squared to the x squared equals 2x. Do you remember on your rules of exponents, what do I do when I have one power raised to another power? So that gives me 2x squared equals 2, I'm sorry. That gives me 2 to the 2x squared equals 2 to the x. So 2x squared is equal to x. So 2x squared minus x equals 0. And I can factor out an x. And x is equal to 0 or 1/2. Yes? All right, let's go. Looking at 79. Let's see how we can rewrite that so everybody's in a 2. What about, so you said here when I have one power raised to the other, you've got to multiply them. What about, that's going to give me 2 to the 2x times 2 to the x squared. What do I do here when I'm multiplying the same base? Add them. So that's going to give me x squared plus 2x, right? As equal to 8. Yes?
Yeah.
All right, so then x squared plus 2x minus 8 equals 0. And what can I multiply? That'll get me a negative 8 and add to a positive 2. Plus 4.
-4, -2.
There you go. So that gives me that x is equal to a negative 4 and 2. How we doing? Got questions? No? All right. You are welcome to stay for another half hour and work on what you got to work on. And I'm just walking around.
Miss White,
Yes, ma'am.
could you do another problem like that?
I can. How about 80? Nine to the 2x, 27 to the x squared, 3 to the negative 1. Right? So all of these, I know I can change to a base of 3. To the 2x, x squared, 3 to the negative 1. 9 is 3 to the second, 27 is 3 to the third. So now all I have to do, I've got to multiply them. So I've got 3 to the 6x times 3 to the 3x squared, 3 to the negative 1. When I am, my properties of exponents, when I'm multiplying the same base, 3 and 3, I can add the exponents. So that gives me 3x squared plus 6x is equal to negative 1. So 3x squared.
Have a good night.
You too. Good night now. I need to go back and look at that problem. Should that be 6x or 4x? 4x. Right here. Because 2 times 2 is 4, not 6. So 3x squared plus 4x plus 1 equals 0. So I need a number that if I multiply, because I get 3 times 1 for AC, and add to a 4, and that's going to be 1 and 3. So I'm going to say 3x squared plus 3x plus 1x plus 1 equals 0. Factoring by grouping, 3x, x plus 1, and 1, x plus 1. So I've got 3x plus 1 times x plus 1, and that gives me a negative 1/3 and a negative 1. Kind of got to go back to those rules of exponents and remember when you're supposed to add, multiply, and subtract. We need to do another one.
I think I got it.